Hello everyone, it's Miss Mullins. I've been receiving a lot of questions about your OMHS assignments this week on atoms and isotopes, so I thought I would make a quick video to help you all. I'm sorry if you hear the squeaky in the background, that is from my chair. So what we're going to talk about today is what is an atom, and then we're going to talk about an isotope. So first, what is an atom? An atom is the smallest object that retains the properties of an element. Atoms can be divided further into smaller particles, protons, neutrons, and electrons. These are called subatomic particles. They're what make up an atom, and they're protons, neutrons, and electrons. There are three subatomic particles. One more time, protons. Protons are positive, and they're found in the nucleus. And I remember they're positive because proton starts with a P. Neutrons have no charge, they're neutral, and these are also found in the nucleus. And then you have electrons, which have a negative charge, and they're found outside of the nucleus. The electrons orbit around the nucleus like a bee orbits a hive. So if you're looking at our at the picture here, the red ball in the middle is the nucleus, and inside of that nucleus you have protons and neutrons. Okay, sorry for I had to pause and come back. So if you're looking at this, in the center the red ball is the nucleus. Inside of that nucleus you will find protons with a positive charge and neutrons with no charge. And then on the outside, the blue balls you see circling in those little orbits, those are the electrons, and they have a negative charge. The size of the nucleus. If an atom, the whole atom, were the size of a football field, then the nucleus would be the size of a marble. Now, atoms are very small. You need a microscope to see them. So we're just saying, pretend that an atom were the size of a football field, the nucleus would be the size of a marble. Even though that nucleus is so small, the mass of an atom comes from the nucleus, making the nucleus dense. So let's stop and talk for a minute right quick. Inside the nucleus, you have protons and you have neutrons. The number of protons is equal to the number of electrons. Protons are positive, electrons are negative. Neutrons have no charge. Inside the nucleus, you have protons and you have neutrons. The atomic number. The atomic number, the number of protons in the nucleus. The atomic number is the number of protons in a single atom of the element. The proton number never changes in an element. So your number of protons never changes, and it's this number that gives the element its place on the periodic table. Elements are arranged on the periodic table by the number of protons they have. Remember, the number of protons is equal to the atomic number. The mass number is sometimes called the atomic mass. The mass number is equal to the number of protons plus neutrons in the nucleus of an atom. So mass number equals protons plus neutrons. An atom itself has an overall neutral charge. This is because the number of protons must equal the number of electrons in a neutral atom or isotope. So if you know the number of electrons an atom has, you know the number of protons. If you know the number of protons an atom has, then you know the number of electrons. They go back and forth. Protons equals electrons. The overall charge of the nucleus is positive. You think of the nucleus, the center of the atom. In that nucleus you have neutrons with no charge, protons with a positive charge. So the actual charge of the nucleus itself is positive. So let's talk about what we can find out with the periodic table. We're looking at the element copper. First, we look for the atomic number. The atomic number is the number of protons. We see that it's 29. Next, we want to find the mass number or atomic mass. You need to round this to the nearest whole number, and here we see that it is 64. 63.5 rounds to 64. Protons. We know the number of protons because it is the atomic number. Protons are equal to 29 because the atomic number is 29. Electrons. How do we find the number of electrons looking at that picture of copper? It's easy. electrons are equal to protons. So we have 29 electrons. The last thing we need to know are how many neutrons are in this element. So you take the atomic mass, which is 64, and you subtract the atomic number, which is 29, and that tells us that we have 35 neutrons. Now, this is one for you to try on your own. This is krypton. So this is the time I would ask you to pause this recording and try to find these answers on your own. For time's sake, I'm going to go ahead and move on to the next slide. So, these are the answers you should have found. If we look on krypton, the atomic number is 36. The mass number, or atomic mass, is 84 because we round 83.8 to 84. The number of protons is your atomic number, so that's 36. Protons equals electrons, so that's 36 electrons. And then we subtract mass minus protons, or atomic number, equals 48. So we have 48 neutrons. Now, I had a lot of questions about isotopes. So I'm looking to get my pen to use to help you all. Okay, so an isotope is an atom that has the same number of protons, because the number of protons cannot change and still be that same element. So an isotope is an atom that has the same number of protons and electrons, but a different mass number and a different number of neutrons. So protons and electrons stay the same, but the neutrons change. When the neutrons change, the atomic mass changes. Okay, example 1, the isotope carbon. Carbon-14. This title tells us the atomic mass. It's 14. See, it says carbon-14, so that tells us that the atomic mass is going to be 14. So let's see what we can find out here. The atomic number stays the same. That's just, that's right there. That's 6. The mass. This is not the mass now. The mass, we have to refer back up here to the name, and it says carbon-14. So now we have an atomic mass of 14. The number of protons, easy. That's our atomic number. It's 6. Electrons equals protons. That's 6. How do we find the number of neutrons? We take the atomic mass, which is 14. Remember to refer to the title. It's called the isotope carbon-14. So we take atomic mass of 14 minus our 6 protons, and that gives us 8 neutrons. So this isotope has 8 neutrons. Okay, here's another example. The isotope of an atom containing 40 protons and 51 neutrons suddenly has 2 neutrons added to it. What isotope has been created? So it tells us we have 40 protons, we have 51 neutrons, and suddenly 2 neutrons have been added to it. So what are we going to do? Well, first, we need to find the atomic mass. Atomic mass equals protons plus neutrons. So we have 40 protons plus 51 neutrons plus the 2 added neutrons. That gives us an atomic mass of 93. Next, we have to figure out which element we're talking about. This didn't tell us anywhere in the directions up here. It didn't say anything about it being zirconium, so how did I find out that this was zirconium? I referred to the periodic table, and remember, protons equals the atomic number, and elements are arranged on the periodic table by their atomic number. So we look, and I find the one that had 40 protons, and zirconium is the only element on the periodic table with 40 protons, an atomic number of 40, so I knew we were dealing with zirconium. So we now know that we have zirconium, and we need to name it by its atomic mass, which is right here. We have zirconium-93. So our answer is zirconium-93. I hope this quick review of atoms and isotopes has been helpful. If you have any other questions, please send me emails or call me. Remember, my phone number is 276-365-2186. I hope you all are having a wonderful week. Look forward to seeing you in class soon. Goodbye.